Hello students, good afternoon. I hope you are safe and sound along with your family members. Children, I am here today with the third video based upon the topic called reflection. Children, last video we have done so many things, but the most of the chapter we have already done based upon the topic called reflection. But I would like to focus on what is called magnification, because this topic is common as far as the reflection and we will study in future called reflection they are concerned, right? So let us start the proceedings of this video by the topic called magnification once again. Children, as you know, by the definition of magnification, it is defined as h dash divided by h. What is h dash? H dash is the size of image and h is the size of object. You know very well. And further, I told you m is equal to h dash upon h, or it is minus v divided by u. What is v? V is taken as the distance of image from the pole of the spherical mirror, and u is always taken as the distance of the object from the pole of spherical mirror. One more important thing as far as the magnification is concerned, it is unitless, it has no units at all, right? Number one. Number two, I just tell you what is the significance or the importance of magnification in our life as far as the mirrors and the lenses, that is I am talking about the reflection itself, right? They are concerned. Children, the concept of magnification is basically used to establish the nature of image. We are left with two possibilities. Number one, either the image will be real and inverted. Number two, the image will be virtual and erect. Need not to tell you, you have already done previously in previous class. Magnification, if it is coming with a positive sign, right? We shall be discussing both the options. If the sign of magnification becomes positive and if the sign of magnification becomes negative, what happens? If it is coming out to be with a positive sign, the nature of image, it will be virtual and erect. Virtual and erect. Alright? Number A. Number B, if magnification is coming out to be minus, coming out to be with a negative sign, then remember children, the nature of image, it will be real and inverted. Alright? So in addition to learning the definition of magnification along with the units, you are supposed to remember forever what is the importance or the use of magnification. It is important from the point of view of numericals, right? So magnification, we have got two options, maybe positive, maybe negative. If it is coming with a positive sign, the nature of image will be virtual and erect, and if it is coming with a negative sign, the nature of image will be real and inverted. Alright? Number two, another important thing. You know, these two are the basic formulae. We shall be going as far as the numericals are concerned with the requirement of the question. In a question, we are given some unknown quantity. So maybe we are given in the numerical the size of image, the size of object, the distance of image, the distance of object. Now, what happens if you are given focal length of the mirror? Then what would be the formula for the magnification? Let us go for what is called manipulation to get our formula in terms of focal length, right? You know very well what is called f is 1 upon f is equal to 1 upon v plus 1 upon u. It is mirror formula, true in case of both the mirrors. Children, if I multiply both the sides by v, what happens? Multiplying both sides by a small v, we shall have v upon f is equal to, it is 1 v upon u. 1 is transferred here. So v upon u will become equal to v upon f minus 1. Take LCM, it will become v minus f divided by f. It is equal to v upon u. So students, we are ready with the third formula for magnification in terms of focal length. So v upon u is equal to v minus f divided by f. It becomes the third formula for magnification. Similarly, you can have the fourth formula for magnification. If you use both the sides here by small u, let us see what happens. We are having 1 upon f is equal to 1 upon v plus 1 upon u. This time I am multiplying both the sides by small u. So multiplying both sides by small u, we shall be having u upon f is equal to u upon v plus 1. 1 is transferred over here. So u upon v is equal to u upon, this is u upon f minus 1. Take LCM. This is, I repeat once again, 1 upon f is equal to 1 upon v plus 1 upon u is the mirror formula. We are now multiplying both the sides by small u. So it will become u upon f is equal to u upon v plus 1. Alright, 1 is transferred over there. So u upon v is equal to u upon f minus 1. Let us take LCM. F will be the LCM. So u minus f is equal to u upon v. Children, we are looking for v upon u, not for u upon v. So take reciprocal of both the sides. So v upon u will be equal to f upon u minus f. This becomes the fourth formula for magnification. So always remember these formulae. I will wish to write down all the formulae for you once again in a line. So you will have in all m is equal to h dash upon h is equal to minus v upon u is equal to v minus f upon f is equal to f upon u minus f. This is an important, answer. You can always expect so many numericals based upon this concept called magnification, not only in case of mirrors but in case of lenses also. Alright? So with this topic of reflection is over from my side. Now let us let us discuss some important questions which are important from the point of view of your board's examinations. Right? So I start with what is called question number 1. The question number 1 is based upon the relationship between the focal length and radius of curvature. So question number 1 is, we have to prove f is equal to r by 2, the relationship for both the mirrors. That is for concave mirror as well as for convex mirror. So children, I told you in the beginning of this video making that these videos are going to be beneficial for you when you start preparing your own notes. Alright? So kindly maintain one register and start making the notes for you. So this is what is called derivation in physics. So you can prove this for concave mirror first and number 2 for convex mirror first. For the sake of proof, as a hint I am giving you, in case of concave mirror, a simple diagram is really enough. This is supposed to be the principal focus, the center of curvature. The ray is taken parallel to the principal axis. It will pass through the focus. If you join here, say this angle, if this angle is theta, this will also be theta, this will be theta, and this angle will become twice theta. If you children make a perpendicular, this is E and let it be N. Alright? So En becomes perpendicular. Students, with the help of this simple diagram you have already done in 10th standard, you are able to prove f is equal to r by 2. Now let us come to what happens, what should be the diagram you are going to make to prove f is equal to r by 2 for a convex mirror. So for a convex mirror, you shall be making this diagram. See, this is F, this is P, a ray which is parallel will go in this manner, it will appear as if it is coming from here. If you extend further and join it by center of curvature, this point is maybe E, this perpendicular is N. Once again, if this angle is theta, this angle will also be theta, this angle will be theta, this angle will become twice theta. If it is theta, it is theta, theta and theta. This is the simple geometry of 10th standard. These two are vertically opposite angles. If it is theta, it is also theta. So this angle is made at the circumference. This will be divided into two equal parts. If it is theta, this will also be theta, this will be theta, and this angle will become twice theta. So with the help of these two elementary diagrams, children, you are supposed to prove F is equal to R by 2 for both the types of mirrors. Let us come to another question. Question number 2 is from my side. Question number 2 will be prove mirror formula for both the types of mirrors. That is, question number 2 from my side is, you are supposed to prove 1 upon F is equal to 1 upon V plus 1 upon U for both the types of mirrors. That is for concave mirror as well as for convex mirror. So for the hint I am giving, for concave mirror, you are supposed to make the diagram. This is going to be the concave mirror, will become the pole, the center of curvature, right in between principal focus. Children, you take an object called AB here. Let us take incident ray going parallel to the principal axis, will go through the principal focus. Another one through principal focus will become parallel. They will cut each other at this point. The image is formed at A dash, B dash. Alright? So with the help of one more thing, from this point E, just make a perpendicular, draw a perpendicular, let it be N. Alright? So with the help of this diagram, you are supposed to prove the mirror formula. One other important thing I wish to tell you, that apart from taking these two rays, you are supposed to take the third ray also in this event. The third ray I have not made yet in order to just remove the confusion. The third ray will be taken from the pole, and since image is formed already from here, so it will be passing in this manner. The two angles, the angle of incidence and the angle of reflection, they are same. Alright children? So with the help of this diagram, you are going to prove 1 upon F is equal to 1 upon V plus 1 upon U. Right? Children, before winding up, I wish to share an important idea with you. As far as the optics is concerned, remember the results are same, the conclusions are same, but the derivations or the paths are totally different. Like we have done it for concave mirror. In the next video, I shall be telling you how to prove this formula for convex mirror and so on. Okay, and in the next video, I shall be giving you some tips just to solve the numerical problems and all. Thank you so much. Stay safe, stay healthy.